So recently I sent my new to me Teradyne equipment up to Eutectic because I was having a problem with this. Now I showed this in a previous video not long ago. This is a new to me unit that I bought used and wanted to use this to replace my old Rototech system right here. This is what we use for thermal flame spraying, okay, that I call spray welding. All right, I did one test weld with it and it did pretty good. I got another powder in and I wanted to go ahead and test this again and make sure that it was working, and I'm glad I did because I was having problems with it. And so I decided to go ahead and send it up to Eutectic and let them go over this and see if there was anything wrong. And I'm glad I did, because what they found out was this guy right here, this is called the T-valve or the transport valve. This was bad. They said this was shot, so they replaced the new T-valve and they went ahead and replaced all the O-rings in the entire torch right here. And working pretty good now. It's supposed to be working really good. We're gonna try it out. So the T-valve, this guy is what you use to adjust how much volume of your media to come through to the nozzle. So it's fed by the oxygen right here. It comes through this valve, the oxygen valve, and then it feeds the T-valve, and you use this to adjust, and it's an important part of the procedure, and it allows the media, how much media you want to come through right here. All right, so your media comes in right through there, your powder. This is your they call the module that slides on right here, and this is what you see me flip whenever we're spraying. All it is like it's like a little gate valve is what it does. It just shuts the orifice off. All right, so the red dot indicating that it's closed. Open it up, it's ready to go. All right, and I'll show you, I've got it in the book right here marked just so you can see it a little bit easier of what I'm talking about. The green being the oxygen comes through, and then there's the T valve or the transport valve, and you adjust that and you can see it allows oxygen to come up and pull the media through all the way to the nozzle right there. And of course your red, that's your acetylene fuel gas right there, okay? So excited to get this thing hooked up. We're going to do another test with it and make sure that it's running. Here's the bottles that the powder goes in, and that's just what it looks like whenever it's all hooked up. I also sent them the flow meter just so they could check everything. This is fine. We're going to hook that back up. And they noticed in the previous video that I wasn't running the heat shields on the gun. When I bought this, it actually didn't come with the heat shields. So thank you, Eutectic. They actually give me the upper and lower heat shields that go to the Teradyne. Very cool. I've actually never used it with these heat shields before, so we'll get these unpackaged and get them mounted. They actually mount to the front of the gun using this screw right here, and we'll see how they work. All right, so I'm going to go hook all this back up to my cart, and I want to do another test with this and make sure that we're ready to go. All righty. All right, so here's the torch with the upper and lower heat shields mounted to it. This is what it'll look like. They've got it designed so that everything will clear, except for one thing. So here's the only issue I'm having now. So I recently showed these simple little mounts that I made to my cart to hold the torch when I'm done using it. And with the heat shield installed, I now cannot put it down there on my my custom mount that I made right there. So I think for this test, I'm going to go ahead and take the heat shield off and not run it. So I'm going to have to make a modification to this, that if I want to keep the heat shield on there, you know, I'll have it to where I can, you know, put it on the mount. So this is just going to have to be modified or redone. All right, so we're gonna do the test without the heat shields. I need to modify the torch so that whenever I go to set this down, I can set it down. All right, go ahead and put our powder on, and we should be ready to go. I just did a preheat on it. I'll do another little preheat just to warm it back up. It's gonna make a loud pop, just so you know. about there. Well, here's the final result for our test welding right there using our Teradyne. This was the first test I did. All right, and then so this is the one that you just saw me finish up right there. Everything looks great. It's working just like it's supposed to now. And what I did is I actually set this outside and let the humidity and the dew get to it and let it build up a little bit of that surface rust overnight, which is what you see on there in this polish section. And what that shows is the stainless type properties that are in this particular powder there. You can see that it doesn't have any corrosion on it. That's one of the benefits of this type of powder, is that it's corrosion resistant, so you're not going to have, you know, rust building up on there like you would the standard carbon steel there. So just one of the other benefits of it. It is harder than the base metal there as well, so you have a more wear resistant surface there, especially for when you're running something like an oil or a grease seal on an application like this. You're not going to have the groove wore into it like you would normally on a shaft, or it's more wear resistant, should I say. Okay, so excellent for bearing fits and seal fits alike. And this was just a this is an old gearbox shaft that I had remade years ago on the channel, except it was a lot longer than that, and I just saved it. It's been in my scrap pile, so that's why we used it as a sample there. This has got your square threads in there on the end. It's got other drilled stems that connect to this. All right, so we're getting ready to start on our next spray welding job very soon. This is the next candidate in line right here. Another industrial shaft for some equipment. It's got a bad bearing fit, this guy right here. So this is what we're going to be building up next. There is a groove cut in it. Somebody used a cutoff wheel to cut off a bearing race, common with this kind of stuff. So before we do our spray weld on it, we'll actually use our TIG welder and just very gently fill this little groove in, and then go to the lathe, set it up, do our undercut. So this one's coming up very soon. All right, guys, so I've been back over here messing with the Stoker engine over here on the G&E Shaper, and I'll get you caught up to where I'm at right now. It's proving to be a very difficult job, not with the setup, but being able to get the tool head set with a tool bit to be able to cut this thing the way it needs to be cut. So let me pull you in here and show you where I'm at right now and show you what's going on. By the way, I still have not indicated it. I wanted to get my tool set up and proven before I go through the effort of getting all this indicated in. It's extremely close. I did some measuring before you know, I accepted the job, and I knew that it was going to be very close, but it should have been, it should be to where we can do it on the Shaper. And just to catch everybody up to speed, these two C channels in here, this guy and this guy here, is what needs to be machined. Keith and Lance went in there and did some build up with the Ultrajet torch, which is a metal powder. It's kind of like brazing in a way. All right, they built it up, and you know, Keith wanted to get this back machined, you know, and have a nice flat surface in there. Whether that's going to actually work or not, we're very skeptical on that. I got a feeling that this may end up chipping out of here. I don't know, but we got to get it set up and start cutting it just to find out if that's the case, you know, if that's going to happen or not. So like I said, we haven't even, I don't even have it tight yet, okay? I did shim this side. When I set up the fixture plate, I told you there was a little bit of rock. So I've got a 3,000 shim on this foot right here. All right, and then that should pull it down nice and square to the fixture plate. Next up, we're gonna go ahead and start getting it indicated. So we've got some machine faces right here. You can tell where this was milled. That was milled. So we're gonna use these faces right here to get this thing indicated. All right, we'll be using the universal table right there, so we'll be able to tilt this as we need. All right, we're also going to have to go across this plane here as well and make sure all these should be the same height. That should all have been milled at the same time there. So we'll have to maybe do some rotating on the table right there to get that indicated. That's going to be a pretty good job, just getting it set up and indicated right there. Then once we get her indicated, I can start going in there and making some light cuts to see if this stuff is going to machine. So you see this tool holder, Armstrong number 42, and that is exactly how it's going to have to be whenever I do this machining. You see how far it's down, hanging down. We're not doing any heavy duty cuts on this, so I'm hoping that this is going to be okay. The tool is designed to be able to use this way, but you know, you never want to hang a tool out like that if you don't have to. So you can see the clearance issue. The back of the this piece right here that holds the tool is going to be right up against this casting right here. I'm going to have the stroke set so that it comes right up, touches it. Now it's not going to damage anything because the clapper box will kick up, but it's going to come right up to that. And I had to relieve the tool bit because it would not clear the back of the piece right here. So this is where this machining is, you know, not being able to set it up in a milling machine because this right here is so close to this area right there. I would love to see the setup that they use to machine this right here, because I'm not sure how they got, you know, all the way across right here, unless they had some really long reach end mill holder and come in there and did that. I'm just not really sure how they accomplished this with it being so close to this right here. See that? All right, so I've been grinding these tool bits right here. These are the 3 tool bits that we're probably going to use. Now whether they hold up to this, I don't know. That's the other problem. This material, you really need to be using carbide to machine that. I'm not going to use carbide because it's going to chip on the first stroke. All right, so we're going to use high speed. It's high speed steel. And you see how I've got them relieved? We took half of the thickness off the height of the tool bits here. These are right and left hand, but you see how I've got them relieved? And that is because, as I was saying, when this tool bit is mounted in that holder right there, the front cutting edge would not clear the back of the part. It was real close, so I went ahead and just took half of the height off the tool bit right there, half of the thickness. So whenever this tool head retracts back, the edge of the cutting tool will actually clear the back of the part. That's going to be right there at it, but it'll clear it. Okay, I'll get it stuck in there so that you can see it, see what I'm talking about. And what we'll do, my plan anyway, they'll know if this is going to work. This tool bit right here, I know it looks like a threading tool, but what this is going to allow me to do is kind of come down and kind of rough most of this out, you know, feed both directions over close to the sidewall and clean most of it up with that if the tool bit holds up. And then what you'd have to do is come in here with these finishing tools and be able to come all the way over to that corner with one tool, put the other tool in, and go all the way over to that corner right there, like that. Again, that's the plan. We don't know if it's going to work, but we're going to give it a shot and see if we can get this accomplished. So next step is getting this thing indicated true to the ram now. I'm starting with indicating the side here, right here. I haven't bumped it yet, but it's actually pretty close. I wanted to make sure that the casting wasn't cocked to one side or the other too much before I tighten the bolts down. So I'm very limited on where I can get in there and indicate this using the ram here. There's clearance issues everywhere you look on this thing, so I have to be very careful that I don't pull this clutch lever and damage something, both the machine and the engine casting. So probably can't see that very well, but we got approximately somewhere between 15 and 20 thousandths out of tram there on that straight line, on that straight edge right there. So I'm going to do some bumping around and get that a little bit closer, and then tighten the 4 feet down. I'm going to be verifying what we were just indicated in here. Okay, this does have some pitting and stuff in there. There's 2 more surfaces that we can check, and I'm assuming everything should be square with that. We got this machine face right here, so I'm going to check that and see where it's at. All right, and then we also have the front of the engine case right here. So this has all been machined. So I'm going to run an indicator across this face as well, and making sure that this case is square to these machine faces here. This surface here isn't proven to be any better than that in there. I'm getting some discrepancies in it, but I think we've got it pretty close. I'm gonna go ahead and turn this on so you can see. We've got it averaged pretty close, but as you're moving across one of these surfaces, it moves quite a bit. So we're just reading around 50 thousandths on the dial right there, and over here it's between 50 and, let's see, what was it? Between 50 and 55 right there. So I'm going to leave it where it's at right now, and we're going to indicate the front face of the case there. We're doing this portion of the casting, and this is far over as I can get it. We're all the way over, so we're able to indicate like half of the housing. We're on 0, by the way. Just showing you where we're at, really. So not too bad. We got a little bit. I'm going to go ahead and bump it, and we're going to use the front face as a reference, because I know that's where the cylinders bolt on right here, and you got your your connecting rods. It's going to go through here, or your piston rod, should I say. So everything should be in line with these channels that's mounted to the front of this engine case. We're indicating across the front of the engine case right there. You can see my indicator there on the other side. I can only get about half of it. Looking pretty good from the outside to the center of the engine, with about a 2/1000th dip in the center of it. So just doing this portion right across here, and then that side from the other side of the shaper. I'm getting this plane here indicated in the on the shaper here. So we've got this large parallel that's sitting across these 2 faces here. I don't have a perfect length end mill. It's going to go from one side to the other, but just note that I stoned these milled faces so that there was no burrs or anything sticking up that was going to hang up the parallel. All right, and this side was 0. We've moved across to this side. I'm showing 3/1000ths difference there, so not much to tweak, but we're going to go ahead and crack the table loose and rotate it so that we can get this averaged out 0/0. We'll go ahead and run it across so you can see. All right, probably hard to see right there, but we are back to 0 at that point there. So we're going to work on getting that side to side movement as close to zero as we can. I'm going to start making adjustments on the worm screw, so we'll watch the needle. We obviously want to drop this side down, but this is a real fine line when you're on the pivot point of this table of going too far, when you're only talking a few thousandths of an inch. See that? See it jump? It's probably going to be too much there. So let's see what it does. Yeah, it's already climbing to the plus, so we'll have to go back the other way with it. So approximate distance of 12 inch end to end. We've got 1/1000th movement on the indicator, and that's as close as I can get it without going too far. It's always really tricky to get the pivot point on the shaper table absolutely zero across a long stretch right there. It just takes a while to get it in, but we've got this 1/1000th, and I think for this right here, we're well within a tolerance that we need to be in. All right, this seems to be about the smoothest one out of all four faces, so we're just doing an initial check from front to back to see how far out we are, because this is the one we're going to have to tilt the table. So it's about 12 to 13. So right in the neighborhood of about 15/1000ths total end to end. And you know, needle's jumping because you know we've got these mill marks in here, and this is a nice smooth surface. What I may do is go ahead and set that parallel on this, and that way we can just indicate the parallel again. But I wanted to just show you on the actual machine face where we're at. Got the parallel sitting in there now so you can see, and yeah, we're getting right at zero there. 15, so about 16/1000ths total. This end's low, so we got to pick the back end of the engine case up a little bit. So we got a clamp on each side of the table. So there'll be these two nuts on each side that we loosen up. Our worm screw is going to be right here. This is the one that we'll adjust. Still got a couple thousandths there. It's easy just to do a little at a time and keep checking it. Still got about two. Let's see if we're gonna be able to get it there. We're gonna move it 1/1000ths on that end. About a 1/2 That's where you really reach that fine line on this kind of machine. And it's best to go ahead and start snugging it down than trying to chase a 1/2 because 9 times out of 10 you make that small adjustment and then you go too far and then you got to just redo everything you just did. So let me check this again. That is showing a 1/2 on that distance of travel there, which is maybe around 11 inches. So I'm going to go ahead and snug the clamps back down and then recheck it. Okay, so we should have the Stoker engine case ready to start machining now. You know, we've done all our indicating, just finished that up. So, you know, we indicated this face here, but this one wasn't really showing very square. This may have moved a little over the years, you know what I mean? But we're gonna be using the front face, which I already showed, for our perpendicularity for the channels that we're gonna be cutting in there. I just finished showing you the top right here. We've already got side to side indicated there. So this is where it's gonna be. So from here on out, we're gonna start getting my, I gotta get my tools set up in here. Sorry about the light. It really is a beautiful day, but the door open right here just kind of blows it out whenever I'm trying to stand here and film. So I have to try to put it to my back a little bit. But as I was saying, we'll get the lantern tool post holder put in here and start getting our tools set up. It's going to be extremely tight, which I already showed. You know, having the tool where it clears off the back and nothing hit right here. So let's go ahead and get our tools set up and give this thing a shot. So this has got to be the most trickiest setup I have ever done, in the shaper at least. This is proving to be a very challenging setup and machining op to do this right here. So let me go over a few things that you have to consider. You always have to make sure that your ram and tool head, lead screw, everything is going to clear your workpiece before you set this thing in motion. So you have to be very gentle whenever you drip the clutch here and start moving the ram. And see how close I am to everything? I've got it about as high, the elevation where I want it. You can see we got about a 1/2 inch clearance there, so there's going to be no more moving of the table up and down because we're limited right there. Notice how close the tool head is to this part of the engine casing. Same as back here. So when this thing is traveling, you got to make sure that it's going to clear here and clear here. So it's already put me in a bind because we're almost in the center of this right here, so I got to be able to go over. So I'm still studying how best way to approach that. Again, you got to make sure the lead screw doesn't come back and bump there either. So I've actually got it set right where it's at. We're going to go ahead and start moving this so you can see. And I just gently move it like that. And you keep checking everything. So like right here, see how close it is? This right here is one thing that I actually did not think about, this whenever I was initially measuring to be able to get down in here. Nor was I considering that this tool head was going to be right over next to this right there. So you can see we've got the tool, it's hanging all the way down. Just a very tricky setup. I'm going to continue to work at this and see what I can do to make this happen. I'm not going to bother with a lot of video until I know that we have this thing cutting and we're getting somewhere on it. All right. I can't even hardly see it cut because the tool's underneath that tool holder. I'm actually running the slowest speed on the shaper, a couple of reasons. Mainly that stuff is tough and you really need to be using carbide to cut that. Okay, I know it's going to dull that tool out, but I'm just keeping things slow and steady so that I can see what's going on here. We'll do what we can to make a little cut across there. I really am having difficulty with this job right here. There was a lot of things involving, you know, clearance issues that I didn't take in consideration whenever I was, you know, measuring and considering doing this job for Keith. And I'm just kind of running out of options here, guys. No matter what I do, if you try to take in one place, you have to give somewhere else. So if you try to change this tool to where you can come all the way over here to the side, well, then you're running into clearance issues in other places on the tool holder or over here, something like that. There's constantly clearance issues that I'm dealing with. I'm going to continue to, you know, brainstorm, take my time, and just keep trying different techniques on this, and maybe making slight adjustments on how I can get this thing cut. I'm really not sure. And honestly, I'm a little worried right now because, you know, I hate to let people down. I hate to let Keith down, and I hate to let all my viewers down that's been watching this project evolve, you know. But this shaper may not be the right machine to do the job. I certainly thought it was going to be. For getting it set up, it's fine. I just don't know if I've got enough clearance everywhere to get it done on this. I'm really curious as if this would be a good job to do on a big mill, to where you can use some long reach end mill holders possibly to get down in there and do some milling on this. But see, even that, it's so close to this right here. You see how close that is? So getting down there with a long reach end mill holder, you're going to be having issues coming up against this, just like I am with the tool there. So I'm not sure yet, but I'll be sure to fire up the camera again whenever we make some more cuts on it, or I continue to figure out what it is I'm going to do here. We've got a new milling cutter here for the shop, courtesy of my friends up at Tungaloy America. They sent me this cutter right here. This is one of their, it's called a Tung cutter. This is going to be used in the DoAll mill, and what we have is this has got a 3/4 shank and 1-inch diameter milling head right there. And this uses the triangular shaped insert, so you've got three cutting edges per insert. This particular cutter has 2 inserts, and they come in a wide range of sizes, this being one of the smallest ones they offer in this size, and then it'll go all the way up to, I believe, you know, 3-inch or larger milling heads that you can attach to an arbor. So we all have these old style insert mills around our shop. You know, we all probably have a couple of these, and I've got a couple myself. These old ones use the you know, old TPG style of insert, and they work and get the job done, but they're getting a little outdated. So it's going to be nice having something like this that's a, you know, a more modern cutter with new style inserts. It's got good geometry there to help pull a good chip off your part and leave good finishes. So this is going to be a nice mill for the DoAll, or use it in the K&T. You know, put this in a 3/4 end mill holder or collet and use it in the K&T. But this is primarily going to be a small mill that I can use in the DoAll. When we got to do a little bit of milling, I can quickly just grab this, put it up in the collet, and go to work with it. So we've got the pack of 10 inserts. Here is a shot of the actual insert part number right there. All right, and of course the case comes with the proper screwdriver and some anti-seize there for the screws there as well. So welcome cutter for the shop. Looking forward to trying this guy out, seeing how well it does, and having it ready to go there on the shelf whenever we have a small milling job for the DoAll. So big thanks to the folks up there at Tungaloy.